In this example, we'll look at an application of systems of equations related to distance. We have a child is walking on a moving sidewalk at an airport. It takes a child 29 seconds to travel 116 feet walking with the sidewalk and 13 seconds to walk 39 feet against the moving sidewalk. Find the speed of the sidewalk and the speed of the child walking on a non-moving ground. The guiding principle in this problem is the fact that distance equals rate times time. We have two unknowns. We have the speed of the sidewalk and the speed of the child, not on the sidewalk, right? So we're going to let x equal the speed of the child, and y will be the speed of the sidewalk. I've created a chart to organize our information. The first column is direction. So in the two rows, we have with the sidewalk and then against the sidewalk. Then the other three columns are rate, time, and distance. I don't know the rate for either direction, with the sidewalk or against the sidewalk, but I do know that if I'm walking with the sidewalk speed is going to increase my speed by the sidewalk speed. So that is, the rate going with the sidewalk is the child's speed plus the sidewalk speed. The time going with the sidewalk was 29 seconds and the distance was 116 feet. Now against the sidewalk, which is my second row, I'm going to be slowed down by the speed of the sidewalk. So my rate is the child's speed, x, minus the speed of the sidewalk, y. So that is x minus y. And then the time was 13 seconds to walk 39 feet. Now I can create two equations to have a system that I can use to solve for x and y. So remember, rate times time equals distance. So in my first equation, I can multiply 29 times x plus y is equal to 116. And then my second equation is multiplying 13 times x minus y is equal to 39. Now if I simplify by clearing parentheses, by applying the distributive property, the first equation is equivalent to 29x plus 29y is equal to 116. And the second equation is 13x minus 13y equals 39. Now I can divide the first equation by 29 and the second equation by 13 to make those easier equations to work with. So if we divide the first equation by 29, and notice I could have actually done that in the first step if I observed that fact. If I divide everything by 29, I get x plus y is equal to 4. And then in the second equation, I can divide by 13 to get x minus y is equal to 3. So now I can actually add the equations in this form because the y minus y add to 0 when I add the equations. So I get 2x equals 7, or x is equal to 3.5. And then I need to solve for y. I know that x plus y is equal to 4. So I know that 3.5 plus y is equal to 4. If I subtract 3.5 from each side, I get 0.5. Now understand what units I'm in. It would be feet per second, right? So the child is 3.5 feet per second. And then the sidewalk speed is 0.5 feet per second.